Ever wondered why you get some chemistry questions wrong, even when you're sure you've got the right answer? Well, if you want to master concepts just like this one, make sure you hit that subscribe button and turn on notifications for Tailspire Learning. You won't want to miss a thing. Okay, let's jump right in with a classic exam scenario. Seriously, so many students walk right into this trap, but after today, you are not going to be one of them. So picture this, you're in your WAEC exam and you get this question. It asks how increasing pressure affects the reaction between marble chips and acid. You think, easy, more pressure means particles are pushed together, so they'll collide more. The reaction speeds up. Seems totally logical, right? But then, you get your paper back, and there's a giant red X right through your answer. The examiner's note says pressure does not affect solids. And you're just left there staring at it, confused. Wait a minute. Collision theory says more collisions means a faster rate. So why is this wrong? And get this exact mistake, this specific misunderstanding costs a whopping 70% of students their full marks on these kinds of questions. Today, we're gonna make sure you're in the other 30%. So here's our game plan. We'll start with the one core rule that changes absolutely everything. Then we'll build a step-by-step reasoning blueprint you can use every single time. We'll apply it to a real question, and then it's gonna be your turn to master it for good. Okay, let's get right to the heart of it. The solution to this whole puzzle actually boils down to one simple but super powerful idea. Here's the key that unlocks this entire problem. Each factor, like pressure or concentration, only works if the physical state of the reactants lets it. Let's break that down. With a gas, sure, you can crank up the pressure and squeeze those particles closer together. That means more collisions and a faster reaction. But a solid? You can't squeeze a solid. Those marble chips are already packed in as tight as they can get. So increasing the pressure on them does absolutely nothing to how often they collide. So, the crucial point, the one thing you need to remember is this. You have to match the factor to the state. Let me show you exactly what I mean. Now that we have our core rule, let's build a foolproof system around it. We're gonna create a reasoning blueprint that you can use to nail any rate of reaction question they throw at you. Step one is our foundation, collision theory. We already know that reaction rate depends on particles colliding more often or with more energy. That's the basic principle. Step two is where the real thinking happens. We match the factor to the state. See, each factor has its specialty. Pressure, it's all about compressing gases. Surface area, that only matters for solids. Concentration, that works for things dissolved in solutions and for gases. But then you have temperature and catalysts. Think of them as the universal tools in our toolbox. Temperature gives all particles more energy, no matter what state they're in. And a catalyst just creates a whole new, easier path for the reaction, which, again, works for all state. And that brings us to the final step, step 3. Before you write down your prediction, you have to ask yourself this one critical question. Can this factor actually change collisions for this specific state of matter? That's the question the examiner is waiting for you to answer. All right, theory is great, but let's put our new blueprint into practice. We're gonna apply this framework to a real exam question, step by step. So here's our question. We're reacting zinc powder and dilute sulfuric acid. Part A asks, what happens if we increase the concentration of the acid? First things first, what state is the acid in? It's aqueous, which means it's a solution. Does our concentration factor work on solutions? Yes, it does. More acid particles crammed into the same space means more chances to collide with the zinc. So our prediction, the rate increases, and that is correct. Now for part B, increasing the pressure. Let's go back to our blueprint. What are the states of our reactants? Well, the zinc is a solid and the acid is an aqueous solution. So what does our blueprint say about pressure? It only affects gases. Are any of our reactants a gas? Nope. So our prediction is no effect on the rate. And that's exactly right. And finally, part C, using zinc granules instead of powder. Okay, what are we actually changing here? We're changing the physical form of the solid zinc. Right, we're changing the surface area. And surface area is a factor that applies to solids. Granules have way less exposed surface area than a fine powder. That means fewer zinc particles are available to react at any given moment. So, our prediction? The rate decreases. Correct again. See the pattern? Every single prediction started by identifying the state. The answer just flows right from there. Let's do one last comparison to really lock this in. Imagine a different reaction. Nitrogen gas plus hydrogen gas making ammonia gas. What's the effect of increasing the pressure here? Well, all the reactants are gases. Pressure absolutely compresses gases, which means more collisions. Prediction, the rate increases. This just shows the whole point perfectly. Look at that comparison. It's the same factor, pressure, but it causes completely different outcomes. In the zinc reaction, with no gases, it did nothing. In the ammonia reaction, with all gases, it sped things up. It's so clear. Same factor, different states, different outcomes. You've got to check the state first. Okay, I've walked you through all the logic. Now it's your turn to put this into action and really make this concept your own. Go ahead and pause this explainer right here. It's your turn. A student wants to speed up the reaction between magnesium ribbon and hydrochloric acid. I want you to suggest 3 ways they could do it and explain why each one works. Write down your 3 changes and, before you unpause, double check. Did you match each factor to the correct state? Take your time. I'll be here when you're ready. You now know the exact strategy that examiners are looking for. First, you identify the states. Second, you match the factor. And third, you can predict with total confidence. You're not just guessing anymore, you're reasoning like a chemist. And that feeling right there, that's mastery. So the next time an exam question asks about pressure or concentration or anything else, you won't panic. You'll check the states, apply the rule, and walk away with full marks. Hey, if this explainer helped you unlock a new level of chemistry confidence, show some love by smashing that like button, share it with your classmates who might be struggling, and of course, subscribe to Tailspire Learning for more lessons that will help you ace those exams. I'll see you in the next one.